Hello friends, today we are going to solve some gate problems. We will begin with 2024, set 2, and it's on deep foundation. In the last videos, we have discussed about the deep foundation. So this problem is related to the net uplift pull-out capacity of the pile. And the details are given to you. A reinforced concrete pile of length 10 meter and diameter 0.7 meter is embedded in a saturated clay having Cu equal to 50 kilopascal, and the adhesion factor alpha is given as 0.5. So how to calculate the net uplift pull-out capacity of a single pile? So this pile, it's a simple problem, is embedded into saturated clay where Cu is known to you, alpha is known to you. So you need to find out the capacity, net uplift capacity. So Q net uplift. So when you are going to pull it, it acts as an anchor. And definitely the pull-out capacity, when it is being pulled out, there will be the frictional forces that will act in the downward direction. So the frictional forces will come over here along with the weight of the pile. So what are the forces that is acting in the downward direction? Is the frictional forces. So unit skin friction will be acting in the downward direction, and the weight of the pile will be also acting in the downward direction when you are going to pull the pile in the upward direction. So when we want to find out the value of net uplift capacity, this will be equal to the unit skin friction into the shaft area. The weight of the pile is not taken into consideration because this is net. If it is total uplift force or total uplift capacity, then you should also take the weight of the pile. Now, as you know, already explained in the previous video that the unit skin friction is given by alpha times Cu multiplied by the shaft area is going to be perimeter into length. So you can calculate, the values are already given in this problem. So the alpha value is 0.5 and Cu value is 50 pi. D value, diameter of the pile is 0.7 meter, and the length of the pile is also given to you as 10 meter. So this will be the value in kilonewton. So net uplift capacity is very simple to calculate, and we can calculate it, the capacity, and this will be equal to the value is equal to 549.7 549.77 kilonewton. So this is the value. And if in the problem, sometimes they may ask you the total uplift capacity of a pile, then the total uplift capacity is given by Fs, the unit skin friction which is acting in the downward direction, multiplied by the shaft area plus weight of the pile. And the weight of the pile, this you have already calculated. The weight of the pile will be the volume of the pile. Volume of the pile, you can find out the cross-sectional area. So pi by 4 d square into L will give you the volume of the pile multiplied by unit weight of RC concrete is going to be 25 kilonewton per cubic meter. So if you multiply it, you can find out the weight of the pile. So weight of the pile can be calculated like this, and therefore the total uplift capacity of a pile can also be calculated. Now we are going for the next problem. The next problem we will see. This is 2023 set 2. The problem is like this: a circular pile of diameter d equal to 0.6 meter and the length of the pile as 8 meter was constructed in a cohesive soil bed, and the properties of the cohesive soil bed is known to you. The total unit weight is given to you as 19 kilonewton per cubic meter, and its undrained cohesion Cu is given to you as 25 kilopascal. The allowable load of the pile, the allowable load of the pile with factor of safety F equal to 3 is dash kilonewton. So you will have to find out the allowable load of a pile. Take alpha equal to 1 and NC equal to 9. So this is the problem. So here you can see you have a circular pile, diameter and length is given to you, and it is constructed in cohesive soil. So you will have to find out the allowable load carrying capacity of this pile. So solution is very simple now. For a single pile, you know how to find out the ultimate load carrying capacity of a single pile. The pile is embedded, and for a load acting in the downward direction, vertical load, and the pile is embedded into the cohesive bed, the ultimate load carrying capacity depends upon this unit skin friction Fs. So it is going to be Fs multiplied by the shaft area, plus also you are going to have the unit end bearing resistance multiplied by area of the pile at its end. So this is the equation that you need to use it to find out the ultimate load carrying capacity of a single pile. And you know, Fs is going to be alpha times Cu. Alpha is already given in this problem as 1. So alpha times Cu into the shaft area will be pi d into L plus 9 times Cu into pi by 4 d square, right? So alpha is 1 and the value of Cu is given to you as 25. The diameter of the pile is known to us and the length is also known to us. So the problem is very simple. Pi and the diameter whole square divided by 4. So if you calculate it, this will give you in kilonewton the ultimate, and then the factor of safety is given. Therefore, it will be very simple to calculate. So if we calculate, this becomes 25 into this gives you 440.60 kilonewton. So for factor of safety F, which is given over here as 3, the allowable load or the safe load will be equal to the ultimate load carrying capacity of the single pile divided by factor of safety. So if you divide it by factor of safety, which is 3, here it is given, you get 146.86 kilonewton. This is the answer. So very simple way we can solve this problem. Now the next problem, we'll see that. Let us see the next problem now. So this is 2023, set 1, and a group of 9 friction pile, a group of 9 friction piles are arranged in a square pattern, are in a square pattern. Maintaining equal spacing in all direction. Maintaining equal spacing in all direction. Each pile has d equal to 0.3 meter and the length is 7 meter. And the soil is cohesionless with phi. It is embedded in soil, is cohesionless. with effective angle of friction is given phi prime uh, as 32 degree. What is the center to center spacing? What is the center to center spacing of the piles in meter? Piles in meter for group efficiency factor eta G equal to 60%. So there is the problem. This problem was asked in 2023, and therefore let us solve it. It's quite simple. You can see that it is based on group efficiency factor. So let's see that it's a 9 friction piles and it is arranged in a square pattern. So if you have got 9 friction piles arranged in a square pattern, there is the 9 piles, 3 by 3 equal to 9 piles, and the spacing is going to be equal in all direction. Each pile has been given, the diameter is known, length is known, soil is cohesionless, phi is known. So what is the center to center spacing of the piles in meter for eta G equal to 60%? So here you know the formula for eta G equal to 1 minus theta by 90 into m into n minus 1 n into n minus 1 divided by m into n. This is the converse Lebesgue formula, where theta equal to tan inverse d by s right. So if you do it, simplify it, there is going to be eta G equal to, this factor will be 0.6, 1 minus this theta has been given to you, equal spacing, maintaining equal spacing in all directions. So theta value is known to us, divided by 90. M, number of piles, is 3, n equal to 3. So here it will be 3 into 2 plus 3 into 2 divided by 3 into 3. So you can find out the value of theta from here, or we can simplify it 1 minus, or we can say that theta equal to 1 minus 0.6, or let us simplify it further, or 0.6 equal to 1 minus theta by 90, and this becomes 2 times 6 divided by 3 into 3. So 3 2 ja 6, and this becomes 4 by 3. So this becomes 1 minus theta by 90 into 4 by 3. Or we can say that 4 theta by 270 equal to 1 minus 0.6. Therefore, theta equal to 0.4 into 270 divided by 4. So this we can simplify and get the value. So if we do it, the value of theta can be easily calculated. So let us calculate 0.4 into 270 divided to this 27. So this value we are getting it as 27. Therefore, we can say theta is going to be tan inverse d by s. Therefore, tan inverse diameter divided by center to center spacing equal to 27. Or you can say that d by s equal to tan 27 equal to, so we can calculate this value, tan 27 is 0.509. Therefore, this spacing between center to center spacing of the piles in meter now can be calculated as d divided by 0.509, and diameter is already given in this problem. So diameter is 0.3 meter. So this is going to be 0.3 meter divided by 0.509. So if we calculate, we can see that it is going to be 0.3 divided by 0.509. This gives you 0.589 meter. This is the answer. So center to center spacing has been calculated. Very simple problem. Now, conceptually, you will have to proceed and you can calculate it. The next problem is going to be of 2022. So another problem, next problem will be so we are going to have now 2022 set 2. 2022 set 2. Now there is a group of 16 piles. A group of 16 piles. So total piles are going to be 16 arranged in a square pattern. So it is in a square pattern. The center to center spacing, that is s equal to 3 meter, it is given, and diameter d equal to 1 meter and length L equal to 20 meter. This is given. Design capacity of each pile. Design capacity of each pile is given as 1000 kilonewton. So it is 1000 kilonewton. So that's also given to you. And in vertical downward direction. So the load is going to be acting vertically down, and eta G is to be used from Converse-Lebedev formula. Converse-Lebedev formula, which you know it, 1 minus theta by 90 into m into n minus 1 plus n into m minus 1 divided by mn. So that you know it. The design value of the pile group, the design capacity of the pile group, therefore, is to be calculated. So this is the problem that has been asked in 2022. So here you can see there's 16 piles arranged in a square pattern. So you have got the piles 4 by 4. Piles, you can arrange it. So m equal to 4, n equal to 4, 16 piles. And the diameter and length, center to center distance is also known to you as spacing equal to 3 meter. D is given to you as 1 meter and L is given to you as 20 meter. And eta G from Converse-Lebedev formula. So how will you find out the design capacity? You know, in the last video I have explained to you that if it is a pile group based on individual shear failure, you know that the design capacity QUG of the pile will be number of piles n into QU, the ultimate load carrying capacity or the design capacity of the single pile, and multiplied by group efficiency factor given by Converse-Lebedev formula. So now number of piles, I know it, 16. This I can calculate. This I can calculate. So let's calculate the value of this is already given as 1000 kilonewton. So this is known to be 1000 kilonewton. And I need to calculate therefore the value of eta G. So eta G equal to 1 minus theta by 90 into m into n minus 1 plus n into m minus 1 divided by m into n. Therefore, where theta is going to be tan inverse d diameter. Now diameter is 1 divided by center to center spacing, which is 3 meter, s equal to 3 meter. So we can calculate this. This will be 18.43 degree. Theta is known to us. Therefore, eta G equal to 1 minus 18.43 divided by 90 into 4 into 3 plus 4 into 3 divided by 4 into 4. So it becomes equal to 1 minus 18.43 divided by 90 into this becomes 24 by 16. So 3 by 2. So let us calculate and simplify it. So easy to calculate now. We can 1 minus 18.43 into 3 divided by 180. 0.6928. So this is going to be equal to 0.6928. This is the group efficiency factor. So this I know it now, 0.6928. So 16 into 1000, 16,000. Therefore, we can calculate now 16,000 multiplied by 0.6928 equal to, this gives you the answer, equal to 11084.8 kilonewton. This is the answer. So this was asked. The design capacity, therefore, of the pile group is 11,084.8 kilonewton. So this problem can be addressed very easily. So this we have done it. Now, the next problem will be taking of 2019. So 2019 problem. So 2019 set 2. A timber pile of L equal to 8 meter. A timber pile of length L equal to 8 meter and diameter D equal to 0.2 meter is driven with 20 kilonewton drop hammer. 20 kilonewton drop hammer. This is important. You are going to use drop hammer. Falling freely from a height. So falling freely from a height of h equal to 1.5 meter. The total penetration of the pile, the total penetration of the pile in last 5 blows, is given to you as 40 mm. And we have to use engineering news formula. Engineering news formula. And the factor of safety to be taken equal to 6 for calculating this, and the empirical factor reduction due to energy losses, that is C, is also given to you in this problem as 2.5 centimeters. So the empirical factor reduction due to energy losses is also given. Calculate the safe load carrying capacity or the allowable load carrying capacity of this pile. So this is the problem. This problem has been asked in GATE 2019. So now if you look to this problem, now here you can use, you have been given that you have to use this formula. And engineering news formula, you have the formula for Q safe or Q allowable. So the allowable load carrying capacity or the safe load carrying capacity as per engineering news formula is the weight of the hammer, which is given in over here, into height of fall of the drop hammer divided by factor of safety, because it is allowable. You will have to divide it by factor of safety, plus what is the set, that is also given in the last, the total penetration of the pile in last five blows set, plus this C value due to losses is also given to you. So this is the formula. This formula is to be used. This is the engineering news formula. Now weight of the hammer is given in the problem. The weight of the hammer is 20 kilonewton. So 20 kilonewton. Now the height of fall of the hammer, if I take it in centimeter, this becomes 150 centimeter, 1.5 meter, that is 150 centimeter, divided by the factor of safety is given to me as 6 into the set. Set I need to calculate. The set means the total penetration of the pile per blow. That is called set. So set equal to total penetration of the pile per blow. So it is going to be 40 mm divided by 5. So it becomes 8 mm. 8 mm means 0.8 centimeter. So 40 mm for 5 blows. So per blow it will be 40 divided by 5. So it is going to be 8 mm, that is 0.8 centimeter. So I can write it here 0.8. And the losses are given already in centimeter, that is 2.5 centimeter. So that is already given to you. So everything is given over here. Now we can calculate it. This is in kilonewton. So the answer will be also in kilonewton. So let's calculate. So if you calculate this, the value is going to be 20 multiplied by 150 divided by 151.5. So 151.51. So this is how you can find out the answer of this question. So the Q safe or Q allowable, this is the answer. So you can find it like this. So friends, thank you very much. Today we are in a position to do 5 problems. In the next video, we will try to do more number of problems. So today we are closing over here. Thank you very much. I hope it will be useful to all of you. And while dealing with the problem, I am also explaining it conceptually so you can learn it much better. Okay, thank you.